For our research project, we chose to analyze the influence of health factors on academic performance among college students, created and presented by Leo Fang, Jackie Freeman, Lauren Goodin, and Taylor Graham. We wanted to conduct research to better understand how our academic performance is affected by our actions and environment. Other research studies have been conducted analyzing various health, lifestyle, and environmental factors and its response to academic performance. A study at Al-Qura University found unhealthy lifestyles measured in lack of physical activity, inadequate sleep, poor dietary choices, smoking, and mental health issues had negative predictive value on GPA. Other studies that we referenced when creating our own study analyzed additional health factors, including alcohol and caffeine consumption, which found negative associations with GPA. We also found studies revealing social media to be negatively associated with exam scores. However, we believe that academic achievement is not solely founded in GPA and exam scores, yet we found it more difficult to find data analyzing academic performance measured in other ways, like study hours or feelings of success. Therefore, we set out to create a research project analyzing several factors of health and how they relate to multiple determinants of academic success, specifically among college students here at Purdue.
Our objective was to analyze how lifestyle factors such as diet, sleep, emotional resilience, and social media usage and their balance impact academic success measured by GPA and study time among college students. Our process was to create a custom Qualtrics survey. We then cleaned our data and analyzed it to identify health aspects most associated with academic performance. Our Y variables were GPA, which reflects the overall academic success and consistency over time, weekly study hours, and academic satisfaction. Our X variables are listed here, and you can see they're specific to each research question, such as lifestyle factors, sleep patterns, health and stress, and social media usage. We'll further explain this as we explain and discuss our research questions. Our first research question is, does a balanced lifestyle measured by exercise, alcohol, and caffeine consumption and sleep influence academic success measured by GPA? The Y variable is cumulative GPA on a 0 to 4.0 scale. X1 is the weekly exercise in hours. X2 is alcohol, which is a categorical variable, whether or not a student consumes alcohol. X3 is the weekly caffeine intake in milligrams, and X4 is the average hours of sleep per night. The null hypothesis is that all betas are equal to 0, and there is no significant relationship between the predictors and GPA. The alternative hypothesis is at least one predictor significantly impacts GPA. After cleaning the data, the sample size reduced to 119 after removing incomplete responses. I transformed alcohol to be categorical and named it consumption due to variability and poor normality of the original data. I used histograms to visualize the distributions of each predictor, and the Shapiro-Wilk test indicated non-normality for all variables, that is, all p-values were less than alpha. I applied a Box-Cox transformation for exercise, caffeine, sleep, and a chi-squared test for alcohol. Overall, the QQ plots showed improved normality, so I proceeded with the transformed data. The Bruce-Pagan test results failed to reject the null and showed no heteroscedasticity, while the VIF test showed no multicollinearity because all values were near 1. The residuals versus fitted plot showed no patterns, so it confirmed the homoscedasticity. Some key results were that all predictors are not statistically significant. However, exercise showed a weak positive relationship with GPA, and alcohol showed a slight negative relationship, while caffeine and sleep had no significant impact. The model explains only 4.15% of GPA variance, while the R-squared and adjusted R-squared suggest minimal contribution from the predictors. The confidence intervals from bootstrapping showed no predictor is statistically significant because all the confidence intervals included 0, and there is insufficient evidence to prove it has a meaningful effect on GPA. The interaction terms, which I chose to be exercise and sleep and caffeine and sleep, did not improve the model, and so I focused on the original reduced model for further analysis. I used tenfold cross-validation for more reliable subsets, and the RMSE from that was 0.4005, which was very close to the GPA standard deviation of 0.3986, indicating moderate predictive power. In conclusion, exercise had a slight positive impact, while alcohol had a slight negative impact, and caffeine and sleep had no significant effects on GPA from this model. However, all predictors were not statistically significant due to a lack of strong evidence. And so for further future research, a larger, more diverse sample could reveal stronger relationships between lifestyle factors and GPA.
Hello, everyone. My name is Taylor Graham, and today I'll present my research on whether the quality of sleep impacts academic performance. Specifically, I investigated the relationship between GPA and four predictors: hours of sleep, sleep consistency, sleep aids, whether or not students use them and what types, as well as weekly study hours or their academic workload. My hypothesis was that students with adequate, consistent sleep and balanced study hours would report higher GPAs compared to those with irregular patterns and a dependence on sleep aids. To begin, I cleaned the dataset by excluding incomplete responses and correcting input errors. After this, the sample size was reduced to a number of 121 participants. I then checked and met most assumptions for linear regression, including linearity and normality after a log transformation. These preparatory steps ensured my data was ready for a meaningful analysis. Again, there was an initial issue with linearity, and I had tried the Shapiro-Wilk test to begin with, but it had failed. After a box-Cox transformation, the p-value was still too low, but a log transformation was successful. So I proceeded with that transformed data. The regression analysis revealed that sleep consistency was a significant predictor of GPA with a positive relationship or p-value less than 0.01. However, hours of sleep, sleep aids, and weekly study hours showed no significant effects, p-value that was greater than 0.05. Despite being statistically significant overall, the model explained only 12.35% of GPA variability, as indicated by the R-squared value. To validate these findings, I performed a k-fold cross-validation. Again, there was 10 folds in the process, which confirmed the low explanatory power of the model with an R-squared value of only 0.115. This suggests that the predictors are not strongly related to GPA, and other factors were likely to play a larger role. In conclusion, I failed to reject the null hypothesis for most of the predictors, except for sleep consistency, which did have a significant effect in a positive relationship with GPA, as shown on the graph to the right. But most of those other predictors did not have a significant relationship. While the model highlights the importance of maintaining consistent sleep schedules, it also underscores the need for further research, again, with maybe some different predictors. To improve this model, I would explore additional predictors, addressing multicollinearity, and increase the sample size for more robust results. For students, these specific findings would suggest that prioritizing consistent sleep patterns would positively impact your GPA and your academic performance. However, hours of sleep alone or reliance on sleep aids would not yield the same significant effects without consistency. Thank you.
Question 4 is whether the impact of emotional resilience on college students' academic performance are the same. There are 7 variables, 1 y variable and 6 x variables, and x1, x4, and x12 are control variables. The null hypothesis is beta A equals to beta 9 equals to beta 10, and the alternative hypothesis is not all of them are equal. The GG plots here shows that each X8, X9, and X10 has a linear relationship with Y, which is represented by the blue line here, suggesting that an MLR model should be proper. The histogram of residue is right-skewed. Shapiro test is less than 0.05, rejecting null hypothesis, indicating non-normality. Thus, normality assumption is not satisfied. BP test here also has a p-value of 0.9232, which is larger than the significance of level of alpha, at 0.05. This suggests that constant variance assumption be satisfied. The pairwise plot above shows that X8, S9, and S10 do not have obvious linear relationships with each other. Results from VIF analysis also suggest that they do not have excessive collinearity issues. Ridge regression addresses multicollinearity by shrinking coefficients as penalty term increases, reducing variance while retaining all predictors. The graph shows coefficients shrinking towards 0, while the table highlights X10 as only predictor with a modest positive impact, which others having small negative effects. And there are several influential cases that influence the variable coefficients. Here's a list here. Robust regression also suggests that only S10 might warrant inclusion since its relatively stronger t-value. And the best subset based on table is Model 2, since first, relatively high adjusted Oscar with minimal predictors. Second, reasonable CP value near 2. Third, low AIC and SBC values compared to larger models. To test null hypothesis, I created a single new variable that represents the average emotional resilience of all three predictors, and then fit a model with this new variable. Then fit the constraint model with the newly created average emotion resilience, and fit the full unconstrained model that treats the predictors separately. Finally, I compare the constraint model to the unconstrained model using an f-test. Since the p-value is above 0.05, there's not enough evidence to conclude that the impacts are same. And the conclusion for question 4 is stress index is primary emotional resilience factor affecting academic performance, while self-rated mental and physical health are not significant predictors, and their impact on students' academic performance are different.
For my question, I wanted to analyze if social media use has any effect on academic performance, specifically measured in study hours. So the variables that I decided to use include daily average screen time, which is a value to 2 decimal places of the number of hours a student spends on their mobile device, the most frequently used app that they use, so whichever social media app that they choose to use more often, which is a categorical variable, self-rated social media addiction, which is a value between 1 to 10 of a student's self-rated addiction level to social media apps, and social media time, which is the average amount of time a student spends per day on social media specifically, which is measured against study hours, the Y variable, the average number of hours per week a student spends on academics. Below is the reduced model with the degrees of freedom, the null and alternative hypotheses. Through data cleaning, the sample size ended up being reduced to 106 values, and the most used app, which are the categorical variable, is transformed into a numeric variable. When running diagnostic tests on this dataset, the Bruch-Pagan test found that there is constant variance. The VIF test found no multicollinearity issues. However, the Shapiro test found strong non-normality issues between all of the X variables, and the Cook's distance found a few influential points as an issue. The transformations that were used to fix these issues include the Box-Cox transformation on the continuous X variables, so X12, X14, and X15, which significantly reduced the Shapiro test values to a normal range. A log transformation on Y, which also had a significant impact on the new Shapiro test. And a robust regression was then added onto the model to reduce the impact of influential points. From these transformations, our new Shapiro test showed significant improvement in the non-normality issue, and the robust regression also improved the model. Confidence intervals retrieved from bootstrapping after the robust regression involved 0 in the confidence interval for X13 and X15. However, X12 and X14 were considered significant after bootstrapping, indicating that there is. However, p-values obtained after bootstrapping showed no significance for any of the variables. The p-values did not produce any statistically significant results. However, the confidence intervals did show that daily average screen time and self-rated addiction are statistically significant and negatively associated with the amount of time a student spends on academics. Overall, though, I would conclude that I failed to reject the null hypothesis for the predictions of the variables selected on academic performance. I would not rule out the idea that social media has an impact on academic performance, and would suggest further research be done with different variables or measuring these variables in different ways or in a non-survey study. The most statistically significant predictors was sleep consistency and the stress index of emotional health. This indicates that mental health and adequate, consistent sleep play a vital role in a student's academic success. Future research could include a more specific sleep study of college students' sleep patterns, and a study could also be done on students and factors that contribute to their mental health. Understanding this could benefit students and optimize their potential success. Our main conclusions for balanced lifestyles that no predictors are statistically significant and have no effects on GPA. For sleep, is that sleep consistency was the only predictor that was statistically significant, and all others have no significant effects on GPA. For our emotional health question, stress index is the primary emotional resilience factor affecting academic performance, and for the social media question, we cannot come to a solid conclusion.